Alright, so this lesson is on the Pythagorean Theorem and its uses. Okay, so this is used when trying to find the missing side of a right triangle. So just to recall, a right triangle has a right angle in it. Okay, so that's what you'll be looking for in all your triangles in order to solve them. Alright, so sides A and B are called the legs of a right triangle, and C is called the hypotenuse. Okay, the equation for any right triangle is C squared equals A squared plus B squared. Alright, so in this particular lesson, we're going to be either trying to find a length of a leg or a length of the hypotenuse. Those are the only two options there are when trying to use the Pythagorean theorem. Alright, so when you look at this triangle, the hypotenuse is always the side not attached to the angle. So you've got this right angle here. The two legs make up the right angle, and the side that doesn't, or the side that's kind of slanted, that's considered the hypotenuse. So when we do this, all we have to do is put our formula in, plug in our numbers, and again A and B, because A and B are just both being squared and added together, they're interchangeable. I just have to make sure that C is on the correct side. In this case, C is X. A squared and B squared, again, I don't have to use, I could put 13 squared plus 8 squared versus 8 squared and 13 squared. It doesn't matter because, again, you're squaring the two sides and adding together, so it doesn't matter. The most important part is to make sure that you have them on the correct side. So A and B belong on the right, C belongs on the left. Okay. Alright, and then so solving this, I just put x squared equals, I punch these in the calculator. This is 64 and 169. I add those together, and I'm going to use my graphing calculator here. You can just use Desmos, that's the easiest. You can use your phone if you want. Right, it's 233, and remember I'm taking the square root just like I did in the distance formula, because it's pretty much the Pythagorean theorem is the distance formula. The distance formula applied to points on a plane. Alright, so I take the square root of that. So take the square root of 233. And that gives me approximately, and I'm going to the nearest tenth, so that's 1 decimal place. So 15 point, and this is going to be 15.3, because you look, when you're rounding to the first decimal place, you always look at the second, and if this is a 5 or higher, this goes up. If it's not 5 or higher, so if it's 0, 1, 2, 3, or 4, then this stays as a 2. But in this case, it's moving up to a 15.3, and we're done with that problem. You'll notice that if you do it right, if you're looking for the hypotenuse, this number should be bigger than either one of these two. All right, do that correctly. All right, so that's if you were doing just the hypotenuse. The one below it, this one's the same thing as that one, so I'm going to skip it. I'm going to do number 3. Now I'm looking for a side this time, so again I'm going to do C squared equals A squared plus B squared. A little bit more work, but still plugging in correctly. Alright, so again, here's my right angle, so this must be C over here. So this is 9 squared equals, I always put my variable that I am looking for as A, just because you'll see in a second, it makes sense to my brain. So I put x squared plus, and then b is 7. So I do 7 squared. So I've got 81. That's 9 squared. Leave that alone. Plus 7 squared, which is 49. And now I'm going to subtract, just like you did when you were doing linear equations. It's just done with squares. Okay, so with this one, all I have to do is my last step, which is unlike linear equations where I have just x equals 32. I have x squared, so all I have to do is take the square root. Okay, so the square root of 32 is 5.65, so this would be 5.7. Okay, 5.7. All right, so again, 4 is done just like 3 is. So number 5, you can see that you've got a right triangle in there, but this whole thing as a whole is not a right triangle. So what you have is two right triangles. All right, so what's going to happen is this 22 is going to be split into two 11 unit pieces, okay? Because I have two of them. When this comes down this, what's called an altitude, this height, it always cuts this bottom in half. So and that's always true with what's called an isosceles triangle, where these two are equal. Again, because we skipped up to some of the other chapters without doing others, I have to kind of fill in the blanks as we go a little bit. All right, so when I do this, I am now going to focus on one of the triangles because all I'm worried about is x. So I'm going to do that triangle right there. So it looks like I'm going to do c squared equals a squared plus b squared. 24 is c. All right, so 24 squared equals x is the variable I'm looking for, plus b, which is 11 squared. 24 squared is 576. Leave the x squared alone. Plus 11 squared is 121. Now I subtract. So again, anytime you're looking for a leg and not a hypotenuse, you have some subtraction to do. Okay, 576 minus 121, 455. So x squared is 455, so x is equal to the square root of 455, which is 21.3 rounded to one decimal place. All right. Okay, 6 is a little tricky, so I'm going to do this one with you. 6, if you notice, there isn't a triangle anywhere, so we have to make one. So we're going to drop this side right here and make a rectangle out of it. And there's a reason why I do that. Okay, so when I do that, this is 90 degrees, just like all the other 90-degree angles I have because I have a rectangle. All right. So if this is a rectangle, x can also be transferred over to here because for a rectangle, if I block this out, the sides opposite on a rectangle are always the same size. You know, when you're doing perimeter of a rectangle, you had two widths and two lengths. So these two we don't know, and so this is a 5 right here. All right, so if this is a 5, this can't be 18 anymore. This has to be 13. Okay, so 13 and 5 make 18, because 18 was all the way across. Now I've got a right triangle because, again, when we talked about angles, if there's a 90-degree angle here, there's also a 90-degree angle there, and I have myself my right triangle now again. And that's what I'm going to figure out. Okay, so c squared equals a squared plus b squared. C squared, I put 16 in there. The variable goes in for a, and b is 13 squared. So 16 squared is 256. X squared plus 13 squared is 169. Subtract that. X squared equals, let's see, 256. 169, 87. Okay, so x is equal to the square root of that, which is 9.3. Okay, rounded to one decimal place. Okay. All right, number 7 is a little tricky. Number 7, you have two right triangles, and you're going to need them both because you're going to make it all the way across here. So, excuse me, you're going to do two triangles. We're going to do the pink triangle here, and then when we get done, we're going to do this yellow triangle here. So, we're going to use that 12 twice. Once for the pink and once for the yellow. So in order to do this, let's just agree that x is equal to, I don't know, let's do k and L. I don't know, I'm making this up as I go along. Okay, so x is made up of k plus L. All right, k plus L added together. So x is equal to k plus L. All right, so when we get k's answer and when we get L's answer, we're going to add them together, and that's going to give me x. All right, so let's do the pink. Pink first. Pink triangle. All right, pink triangle looks like I need a leg. Okay, so I'm doing c squared equals a squared plus b squared. C squared is 29. A squared is L, that's the variable I don't have, plus B squared, which is 12 squared. 29 squared. 841. L squared, I'm gonna leave alone, and that's 144. So subtract 841 minus 144, 697. So L is equal to the square root of 697, which is 26.4. All right, 26.4. Okay, so that is part of it. So down here, I'm going to put down here 26.4. I have part of it. Now I have to go and do the yellow triangle. All right, yellow triangle looks like c squared equals a squared plus b squared. Okay, c squared is 14 squared equals a squared, which is my k, I don't know, plus b squared, which is again 12 squared. 14 squared is 196. K squared, leave it alone. 12 squared is 144. Subtract. That looks like 52. K squared is 52, so K is, let's see, 7.2. So I'm going to go over here and add 7.2 to that. So X's final answer is 7.2 plus 26.4, 33.6. And again, that's rounded to the nearest tenth, approximately. And that's how you do that problem. Okay. So sometimes you need part of the shape, like this one. Sometimes you need the whole thing. It all depends on what X is. All right, so on the back side of the page, we're going to skip the next two problems, and we're going to start talking about some word problems. The word problems, the whole idea on this is you're trying to make a right triangle. So what I would do is just make a right triangle, and then try to match it to the story. Okay? So I made a right triangle. A roofer is leaning a 16-foot ladder against the house. So anything leaning. Well, this looks like it's leaning, so I'm going to put this as my 16-foot ladder. This is my house, okay, here. And it says the base of the ladder, which means the bottom. Bottom of the ladder is 5 feet from the house. So here's the house, here's the bottom of the ladder, so this is 5. How high up the house does the ladder reach? So they want to know, did it get, I mean, I have it drawn to the top of the house, but technically I don't know that. But I'm going to put my X right there. Okay, and then I just have to use Pythagorean Theorem again. Okay, so C I have, that's the ladder. X is my variable, B is 5. Okay, so 6, that's 256. X squared plus 25 minus 25. So X squared is equal to, what is that? 231. 231. Okay, so X is equal to, let's see. 15.2. Okay, so my answer is 15.2 feet. That's how high up the side of the house the ladder is sitting. Okay, so let's do number 11. Number 11, we have a rectangular deck. Okay, and rectangular means there are right angles on all of my corners. Okay, a diagonal is something that goes diagonally through. Okay, like you were doing a word search, you could circle a word that's diagonal. You'd be circling it kind of in a up-down kind of idea. All right, so it says the deck is 10 by 23. So this is 10, this is 23, and they want to know what the diagonal is. So in this case, this is looking for the hypotenuse. So I put c squared. I don't know this time. We like these because this is the least amount of steps. We don't have any subtracting to do. So this is going to be not too bad. This is 123 squared. 529. So x squared is equal to 629. The square root of 629. 25.1 feet. That's its diagonal. That's the dimensions of the diagonal. Okay. All right. Number 12 actually jogged. Okay, so you've got east and south and whatever. If you don't know your directions, north is this way, south is that way, east is this way, and W is that way. All right, so Ashley, we'll put Ashley down here. Hi. All right, and she traveled 3.4 miles east. Okay. Then she traveled 5.7 south, and they want to know how far she from the starting point. So the shortest distance between 2 points is a line. So we draw a line from where she stopped, from where she began. And again, I'm looking for x, so I'm looking for the hypotenuse again. Okay, so x squared equals 3.4 squared plus 5.7 squared. X squared equals, put those in the calculator. The beauty about using this graphing calculator is I can do it all in one swoop. Desmos, you can do that as well. 44.05, but remember I got to take the square root of that. Which is 6.6. 6.6 miles. Okay. All right. Last one. Again, if you make a triangle, you can figure out. Now, think about real life. All right. A 30-foot support wire is attached to the top of a pole. So here's the wire attached to the top of the pole. Okay. So 31's in there. And it's the top of a 25-foot pole, and they want to know how far from the pole's base, remember base means bottom, does the wire meet the ground. Okay, so where they want to know this spot right in here, so they want to know how far away is it. So that's your x. Okay, how far away is this thing like staked to the ground? Okay, like attached to the ground. How far away from the pole is it? Think of also like tents. If you've ever put a tent up before with poles and strings, you need to pull this really tight and keep the pole up and down in order for your tent to stay up. Anyhow, so if we were going to do this problem, we would then do c squared equals a squared plus b squared. C squared is 31. X we don't know, and then 25 squared. 31 squared is 961. 25 squared, I believe is 625. Yep, 625. Subtract those. 961 minus 961 minus 625 is 336. And that's x squared, so x is equal to the square root of 336, which is 18.3 feet. So I'll put that. All right, and that's how you do it. All right, so good luck on that classwork.